So this is a fairly techie talk. There'll be a lot of code examples and things, but yeah, I hope I won't lose you. So I'm Phil Norton, developer at Code Enigma. I write a lot on Hashbrand code, and also the Northwest Drupal user group co-organizer. So we're based in Manchester, Cheshire area, yeah. I've been doing Drupal for about 15 years. Built a lot of websites. Been coding for probably about 20 now, so I look older than I am older than I look. There's a load of code examples in this talk. Don't worry about writing them any down. It's all available online. So this QR code will take you to the slides that I'm using right now. And in that page, you'll see links to other resources and things that I'm going to use here. All the code is available on that bit.ly link. So that's a Drupal module that has all of the code examples I'm about to show you. Yeah, so don't worry about losing anything. I can't show you any examples running, but I've got a video later that should go. Okay. Yeah, if you want to know any more, then feel free to catch me afterwards. I'm happy to talk through this stuff. So yeah, services then. So why am I talking about services? Like, this is a kind of a core subject, really. I actually gave a version of this talk back in Drupal Camp London in 2018-ish, and this is a bit's changed since then, so I've kind of updated and changed the talk since then. But I think now is a good time to get into services. If you're used to the hook system in Drupal, that's being deprecated, and we're replacing it with service hooks. And I'll come into service hooks later, but I think now is a good time to get into how to use services and things, because it will set you up for using those services later. So then what is a service, obviously? So it's used in all parts of Drupal, and many modules come with their own services as well. It's built on the Symfony service container, so it's a Symfony component in its own right, but there are some Drupalisms, as in always. There are always Drupalisms. So I'll try to introduce you to those in a bit. That wasn't me. But essentially, a service describes an object. So if you ask Drupal for a service, you get an object which you can then use to do things inside Drupal. And dependency injection is used to inject services into other services. So that it's an automatic service that gives you that sort of ability to make complicated services through just a single API call. They make unit testing much easier. I'm not going to go into unit testing. I can show you unit testing afterwards if you like, but it makes your life easier. If you've ever used Drupal 7 and kind of tried to unit test functions, you'll probably realize how difficult that was. The only difficulty in testing a service is actually the architecture in a Drupal site, so like setting up your pages and your content types and things. Your services is actually fairly easy to test. And I think they're simple to use. Maybe it's because I've been using them so long. But they come with a lot of power as well. So, yeah. So using a service. So you might have seen this kind of example of code in the past, where you use the Drupal service class, not object, class, to get a service out of Drupal. Thing is the string, so is what the service is called, and you get an object out of that. So for an example then, we can use the alias manager. So this is a service that's used to translate paths into different sorts. So what we're doing here is get path by alias, and we pass in some path, and we get the internal Drupal path out of that. So it might be, taxonomy 123 or node 123 or something. So, yeah, this is kind of like there's a lot of complexity behind this code. The path alias manager has about 15 dependencies, if you sort of count up the stack dependencies available, including things like database access and language constructs and stuff. So we don't need to worry about any of that. We just need to ask Drupal for our service, and it gives us that. You can also chain them. So this is quite common to see, sort of chaining things together, because effectively out of service you get an object which you can then use and chain through in that way. So what service exists? Well, there's actually quite a lot. So this drush command, so Drupal get container get service IDs gives you a big list of service IDs. There's about 600 just in Drupal core, and about 550 of those are in this form of date formatter. Date formatter being another service that you can use to format dates, hence the name. Some of them are also in this kind of long string interface stuff, and that's for auto-loading, which we'll come on to later, but yeah, there's a big list of them. So rather than sit here and explain exactly what's in there, you should probably go and have a look, really, because I'm not going to go through 600 services in a talk. So most of the time, then you don't want to be actually using this service method inside the Drupal class. You want to be running your code. Unless you're running your code in a hook, in your procedural land, you want to be injecting services into your own code so that you can start using them. And Drupal handles all this automatically, figuring out what services are needed for what things, and this is called dependency injection. So I thought I'd do a quick 3-slide introduction to dependency injection in case someone here is a bit lost. So it sounds complicated, PHP, not even just PHP, but object-oriented programming is sometimes the science of long words. Like polymorphism is a horrific word, but there we go. So dependency injection is basically injecting things into your classes or objects so that you can use them instead of baking them into the class themselves. So let's say you had this class. This is a page class. This isn't Drupal code at all. This is just demonstration. But inside that page class needs a database connection. So obviously in our constructor, we put in a connection to the database, and then we pass in our database parameters to the page object as we're making it, which then creates our database connection. This, if you've never seen code before, is extremely brittle. If you need to change anything, you have to change most of the code here just to change a database parameter. And more importantly, if you want to swap between MySQL and PostgreSQL, you then have to go into these classes and start changing them line by line. So kind of makes the code difficult to maintain, difficult to change, and yeah, difficult to use. So dependency injection then. So what we do here is we change our database parameters into a single database object, and we create that externally, and then we pass that into the object as a constructor parameter. And this actually happens in Drupal. We're passing. Sorry, yes. I'm going to fiddle with some light switches here. That one I want, yeah. How's that? Yeah? Good. So we've created a MySQL database object, but because we're passing it in as an interface to a database connection, we can pass in any type of object that connects to a database. So it could be an SQLite database connection. The page class doesn't care about that as long as it's a database connection. So if we want to change the entire structure of our database parameters, we just have to change that database object. If you're familiar with solid principles, this is the S of solid, making things, you have to have an excuse to change a class. And in this case, we don't need to change the page class if we want to change the database model. So let's create some of our own services then. So services are defined in a a services.yml file, and this is held in your module directory. So they're defined through YAML, which is pretty ubiquitous in Drupal. So what we've got here is our service definition. So we've got, can I use my mouse? I can. The services keyword, and then we have the name of the service. So it's actually common to prefix the name of your service with your module name so that they don't clash in with other services that might exist in Drupal. And then I've named my service simple service. And then we just point that to a class, and that's it, really. This is a simple one. And then this is the class for the service. This is a silly example because I just wanted something for the class to do, but it returns an array, a blank array. But yeah, it's a service that does a thing. And then we can use that just as any normal Drupal service. So we can say, give it the name of our service. We get the service object, and then we use that object to do whatever we want to do. More commonly, though, you'll probably want to pass in some arguments to your dependencies, to your service things. And we use the arguments directive here. So the arguments is the arguments we're going to pass into the constructor. In this case, I'm using the password generator service, and I can tell it's a service because it has an @ symbol in front of it. And the password generator is, I'm going to pick on that quite a lot in this talk. It's a simple service, has no dependencies of its own, and it's quite obvious to see what it's doing. It produces a random string of characters. There's a few different things you can pass in like this. So you've got a service with an @ symbol in front. You can also create parameters in service files. So at the top of your service file, you might have a parameters list and name some parameters out, and you can get Drupal to change those on the fly through your settings.php file. And they can be passed into your service layers to change things. You could even just pass in a string. Some of the Drupal factories use strings to change, how they interact with what objects they're creating. So in this case, I'm just passing in the string config. But for this talk, I'm going to stick to passing in just services. So then our password generator service is passed in like this. I don't know if you've seen this sort of code before. This is called constructor property promotion. So I'm not actually making a property inside my class. I'm just passing in this protected keyword here, which means that PHP will automatically elevate that to a class property so I can start using it. That's a good thing because it means that my constructor is now very simple and I'm not doing much in the constructor. And it makes my code kind of clean, I think. The alternative to this is to have password generator as a class property, and then say, this password generator equals password generator, which to me is a bit boilerplate code. I try to avoid those situations really. So, and then inside our class, we can then start using our service. So this is the password generator service in use. So what I'm doing is using the generate method to generate a 12-character password. And we then make a function called, generate 12-character password, which returns a string. And that will look like this. So I ask the Drupal for the service, I get the service class, and I can start using it straight away again. Good. You can auto-wire services as well. So remember I talked about the interface thing at the beginning. This is an example here. So this line of code is buried deep in the core.services.yml file of Drupal core. And it's actually a Symfony construct, and it basically says that if this interface is used, then it's probably to do with this service, which means if I tell the service handler to auto-wire, so I put in this auto-wire equals true, and then all I need to do, you can also tell your entire service file to auto-wire together, just using this little default thing at the top. All I need to do then is to tell the class that it should accept a password generator interface, and Drupal will see that and swap it in for the actual service that's intended. So this putting this means you don't have to write your arguments. Drupal will figure this out on its own and give you the appropriate classes, or objects, I suppose. Yeah. So controllers and forms, actually. So these work slightly differently. So obviously, controllers don't have a service.yml file. You don't define them in your services. Instead, they implement this interface here. If Drupal sees this interface being implemented, it will instead call a static create method, and that will then be used to create the object and return it. And in the create method, then you decide on what services you need inside your object. So this is an example of a controller. So let's say we wanted to print out a generated password in our controller. We would then need to inject the password generator into the service. So we use the public static function create here. The container here, it's basically an object that contains all of the services available to Drupal in a big object. So we're just asking it to get the appropriate password generator service, and then we return an instance of the object. That's pretty much it, really. So plugins are the same. So plugins you might use for search API plugins, if you're at the search API thing. Views plugins also exist. You might have a migration handler plugin. So all those plugins use the same kind of mechanism, but in this case, they use this interface, container factory plugin interface. Has the same create method, the same methodology of generating your objects. But in this case, you just need to be slightly careful. So new static is going to call a controller, and you have to pass in your some of the arguments you send that are sent through Drupal to the controller, because things happen upstream with those arguments. But generally, after that, it's the same thing. So we get our container, we get the service we need, and we use that. So hook service classes. So I mentioned that service classes were coming. So this is new in Drupal 11.1. So if you use procedural hooks, if you don't know what hooks are, find me afterwards. So basically, hooks allow you to interact with all kinds of things in Drupal. It's kind of one of the key principles. But procedural hooks are being replaced by an object-oriented approach. Some of these hooks aren't being replaced. So things like hook install, hook update, and preprocess hook are being kept because they're either low-level stuff. So hook install has very few dependencies, so they wanted to keep it as simple as possible. Preprocess hook works in a theme. Themes don't have service files, so you can't have service objects for them. Other than that, there's a lot of stuff going on. This node reference here is for the change record, which has a load of detail on service classes. But essentially, it looks like this. So I'm going to auto-wire this service, but I'm going to put it in the hook directory. And this is going to contain all of my hooks. And what I want to do is interact with node hooks. And so if I need to find a hook, I can go into the hook directory and find all my hooks there. They're not going to be in the module file. And it looks a bit like this. So we're using PHP attribute here to say hook node insert. And this will work in exactly the same way as the usual hook node insert. So when a node is inserted into the database, this hook will be triggered, basically. So this registers the insertion event inside Drupal. So for the time being, you're encouraged to use what they call a shim procedural hook in the usual place, as in your .module file, but you need to prefix it with legacy hook here. So Drupal will see that you've got legacy hook and a new object-oriented hook, and it will only call one of them. So it will use the object method instead. But inside our procedural hook, I've got a reference to the service handler, and I'm basically calling the hook manually. So this will work now for Drupal versions under the 11.1, but it'll also work in the future versions as well. I think after conversations this morning, I think a lot of you use services like this anyway, so yeah, it's kind of makes sense to upgrade. So in the future, if you want to drop support for legacy hooks, you can add in this attribute to the top of your services file, where you say hooks converted equals true, and this will stop trying to look for these legacy hooks from now on. Gives you a little bit of performance boost, but yeah. So that's in Drupal right now, which is good. You can also tag certain services, so give some special abilities, so listening to events or controlling access or caching or whatever. So the simplest tagged service I know of is the event subscriber. So we have a service here called event listener service, and that we give that a tag of name equals event subscriber. And that means that Drupal will see this and it will register it as an event subscriber and call this public static function get subscribe events. And with that function, we can then register different events that get triggered or will trigger this class to be used. So in this case, we're just doing the request event, which is when a request hits Drupal. We can do various things with that information. Kernel events has a lot of different different events in it. It's probably good to have a go and have a look and see what's in there. Everything from a controller has been decided to a shutdown sequence, which is actually quite useful because it lets you run code after the site has been generated after the fact, so the user isn't inconvenienced by a slow page load. That's actually how the cron handler works. It'll run code after the fact using an event subscriber. There's also auto-configure. So in the same way that we can auto-wire, we can auto-configure stuff. So if we leave out the tag name from our event subscriber, Drupal will see that it extends event subscriber interface and will automatically pick that up and give it a tag behind the scenes. This is a Drupalism, by the way. This isn't part of the Symfony component stuff. But it means that we can just write our event handlers and they'll get picked up automatically, which is great. So for some tips then for creating services. Yeah, don't use Drupal service unless you're in procedural land. Use dependency injection frameworks instead. Use solid principles. So create small, easily maintainable classes that do one thing and one thing only. Don't have services with lots of arguments. If you've got 5 or more, that suggests the class is doing a bit much. So it's probably best to break that down a little bit. It also makes testing hard if your service is doing a lot of stuff. And yeah, keep constructors as simple as possible. So I use the property promotion stuff to keep them as single line constructors. Just assign your dependencies to properties. Don't have services that just hand off their dependencies to other things. Each service should have the service it needs to do the job it needs to do. If you're writing code if you've got a class that has, or a service that has a service, like you inject the password generator and then you pass it on to another class to do the password generation stuff, that creates a tight dependency between those two classes and can create some brittleisms there. So it's best to separate your concerns as much as you can. Even consider not creating a service. If the class has no arguments or no dependencies, then does it need to be a service? Probably not, unless you need to alter the class to do something, in which case you need to register it as a service to allow Drupal to do that. And then finally, we're going to alter some services. speaking of altering. So all services inside Drupal, because they are mutable objects, can be modified to change their functionality. And we can do this in two ways, depending on what you need to do. So there's decorating and then altering. So we'll look at decorating first. So this is a standard service in our services.yml file. And we're putting in the decorates attribute here. And we're saying password generator, again, picking on password generator. But what we're saying here is that this service will have the same arguments and tags as the original password generator service. Which means that we can extend default password generator and it gets everything that we need to do. So the default password generator, the allowed characters has upper and lowercase characters and numbers. So here we're just having lowercase letters, which means our decorated password generator will only create lowercase passwords. Important thing about this is that the original service still exists, so we could still use password generator, but we can also have this modified password generator thing to do our own stuff. So if you want to replace them completely, which you can do, you can use altering. So this is a little bit more complicated to set up. So you need to have this special class called service provider, and it needs to start with your module name in Pascal case. So it'll be module name service provider, and that needs to extend this service provider base class. But that comes with two methods in it. We've got register and create. So register, you can forego your services file and register your services through an object-oriented approach like this, which is useful if you're doing highly dynamic sites with lots of services that might be generated through other means. I have to admit, I've never used register, so let me know if you have. But there's alter, which we can use as an alter hook, so we can alter the services as they get passed through the system. So altering services is particularly powerful, and I've used this several times when you're integrating with an API. So you can stub or mock out your API layer completely and replace it with a subset of data, which is really useful if you've got an API that's locked down or has a cost associated with it, which means you don't need to let everybody have access to the API. You can just replace it with a stubbed version of the API. And I do this a lot. It's especially good with things like Cypress testing, because you can just replace it with a mocked version of the API, and your Cypress tests have then a known quantity. So what I'm going to do is replace an API for the joke API. So if you've not seen the joke API, it's a free API that returns jokes. They're not necessarily funny, but they are jokes because they're in the joke API. So let's write a wrapper for the joke API here. So we've got our services file in our module directory, and we've got a class here, and we're just going to auto-wire it to accept some parameters. It's cut off at the bottom there. But so the joke API is dead simple. The joke API module that I've got on GitHub is a lot more complicated than this, but essentially what we're doing is we're passing in this interface, which is this is HTTP interface. This is how you make web requests inside Drupal. We're using that interface to request from this URL, which is the endpoint of the joke API. And because that request is JSON encoded, we need to JSON decode that and return that as an array. Get rid of that thing. If that makes sense. So what we could do now is basically when we run getJoke, that will return a joke from the API, and we can then pass that to do whatever we need to do. So the alter service for this, if we make another module and we call that joke API stub, and remember in Pascal case that should be joke API stub with upper characters, service provider, which then extends the service provider base. Looks a bit interesting, this, but the critical thing is we've got this container. This is container builder, so it contains information about all the different services in Drupal and what they're doing. before actually making them as actual classes or objects and things. What we can do there is get the definition of the original joke API and just set the class to be something else. So what we're doing here is we're swapping out that single class to be our own stub class. Stub class then has this incredibly funny joke in it. So basically, if we call getJoke now, it will return a single joke every single time we use it. I should have an example of this using, yeah. So this is an example of the joke API and the stub module in action. So if we get joke, I've built a form around it so you can interact with it easier. Yep. So what do you call a group of 8 hobbits? A hobbite. I think comedy is optional for this. So we can filter it so we can type in programming and get programming things. The metadata shows us all the information that was in our JSON API. So let's go off to the module directory and swap out our joke API for a stub. There we go. So what it's doing now is it's activating that service provider module and changing the class internally. So it's now not using the joke API, it's using this internal JSON array. So we go back to our form and now click get joke. It will only come up with this a web developer walks into a restaurant joke, and no matter what we try to filter it, it'll just return the same thing. Obviously, you can program your stub API so that you can change how it interacts with user input. This is deliberately incredibly simple, just to keep things easy. What am I doing here? Yeah, so there's much more to Drupal services. You can look up access control services. These are services that are to do with, saying if a user has access to something or not. Factories, which are services that create objects, not necessarily so you don't have to program all of your every single object you need into a service. Lazy services are only instantiated when they're called, which is kind of weird, but yeah, it requires a little bit of Symfony parlance to get them working. You can have public and private services, so actually a private service is something you can't really see. You should only know it by name, and that means it's sort of hidden away from use. And then service aliases, so if you want to deprecate a service and move on to a different name of that service, you can still alias it, and so people can still use the same thing. It doesn't break anything going forwards. And then some resources finally, so services on DI on my own site, dependency injection, so I've written a fair amount on this sort of stuff. It's all available there. Yeah, as I said, the custom code, so every example here, plus a load of other examples, are all in Drupal Services example, which is a Drupal module. Joke API is there as well. Joke API contains a submodule which has got the stubbing in it. So Drupal at your fingertips is always a nice resource, and that's a big, if you've not seen the Drupal book yet, that's a nice page. And then finally, there's the Drupal.org page on Drupal services and Drupal files, services file on that bit link, if you need to look at that. I think it's a bit detail free, so yeah. But any questions? I need to throw this thing around. Yeah. Do you want to come and get this?
Is there any drawbacks from auto-wiring? It sounds very convenient. Is that actually a downside to it?
I'll repeat the question, yeah. So the question was if there's any downsides to auto-wiring. Oh, thanks, Chris. I think...
Sorry, that is switching on, so you can use the handheld or I'll switch on for you. So.
No worries. I just thought...
You know what you're doing. I'll sit down.
It's all right, I'll repeat the questions and we can go on from there. So I think the only downside is that you need to, like if you're making your own services that need auto-wiring, you need to put in the auto-wiring clauses there, which kind of creates a lot of mess in your services file. But other than that, I think they're okay. You just need to be careful of some things that don't have auto-wiring. So for example, the caching system doesn't have an auto-wiring alias to it, which means you're forced into using arguments anyway. But that's just because of how the caching system works, because it's a factory. And so the thing you get from the factory system is actually the thing you get from the caching system is actually a factory where you create your caching instances from. So, yeah, just I would say be slightly careful that you're getting the right thing, rather than just assuming that because you've used an interface that you're getting the service that you expect. But yeah, that would be about it.
Would there be a problem at the end as well? So, for example, you had a service, right? Like you had an interface, and
I think this is on now.
Yeah, that's on now. You can grab it, say.
Sorry, I was wondering, like, say if you have one interface and one class implementing that interface,
Yeah.
and then you're using that as a dependency in another service when you started the project, so it knows which dependency to use. But then, down the line, you created another implementation of the same interface. So the AutoWire would try to figure out whether to use the old implementation or the new implementation. Would that be a problem down the line?
Yeah, that would probably cause an issue. The auto-wiring is built on the Symfony container stuff, so I've not actually tried to do that, but I'm sure it would have a problem with setting things up. Because Symfony is usually very good at catching stuff like that.
Right.
So yeah, just stop you shooting yourself in the foot. But I can imagine if you tried to register the same interface, it would either complain or you just have the second one as the interface that you had. Yeah. A couple more.
I don't know how to do that.
So as site builders and developers of Drupal, we rely on services quite a lot, especially like in the examples like you used, like the alias service, for example, path alias service. Mm-hmm. But my question is, in what sort of situations do you find that you end up creating custom services? Is it, for instance, when you're making a new custom module and you like to rely on services as much as possible? Or, yeah, in what situations do you find you make custom ones?
So if I need to do things that are outside of the scope of what Drupal does, then yes, I'll create a service for that. So, for example, at the moment, I'm building an interface against an API, which doesn't have a Drupal module, so I've got to build the module to do that interface. And that needs lots of services to kind of connect to the APIs and also handle everything that comes out of the API into the database and things. So I'm creating services there to do the work between Drupal and the API. Yeah. But yeah, not all modules will have a custom service, I would say. Some of them will just have a controller that you inject Drupal services into, and you can do things with them inside that. It depends on what your needs are, I guess. Because as I said, if it doesn't exist in Drupal, you might have to make that, and therefore you have to get Drupal into Drupal somehow. But I did say, if the class that you're trying to use doesn't need any arguments or anything, or sits outside of Drupal, you might be able to just create an instance of that. So, for example, the MySQL Office interfaces they have a load of stuff that you can use to interface with the MySQL, the Microsoft APIs. They'll give you these sort of classes that you need to interact with that API, but the authentication layer is kind of like you deal with that. So obviously it's like I can pull that information into the service classes I'm using, but I've got a built-on code to connect to the APIs and do all that kind of stuff. So Yeah, I do a lot of work with APIs, if you can tell. I think it was a-
For example, if you have a PHP, non-Drupal PHP library that you wanted to use in Drupal, then one of the options is you create a custom module, you add the PHP library as a dependency in the composer, and then you just create a service in Drupal. So services are more like the Drupal entry point for those external PHP library. Otherwise, you need to end up using like a new and then, like initiate the class as and when required. Other one is caching is a good example. So caching each of them, like if you see cache.default, that's a default bucket. So based on the backend that you use. So imagine you are using a memcache server. It has a different bucket you can define for each caching. So say you're creating a custom module which has a lot of caching and you want to provide a separate bucket size, then you can define your own custom bucket. So you can just say, like your, let's say you're creating some playground or something, then you can say cache.playground as your implementation, and then it can have a different bucket size than the normal, Drupal specific ones.
I think I've got an article on that on my on my site, actually. Custom cache bins, yeah.
Oh, yeah.
So this is exactly what you were talking about. Like you've got cache.default, which is the default bin, and then somewhere down here we're defining our custom bin, and we're injecting that into our module there. So
Wow. Almost like I read your blog post.
but I found this technique was useful because the default cache bin, the database bin, has a limit, size limit, as you said.
Yeah.
I think it's about 10,000, which wasn't enough for our purposes. So I had to extend that to make another cache bin, which I could then really go to town on the cache.
Yeah.
Yeah.
And Memcache said even you can put a cache bin in a different cluster if you want, because it's a different access.
Exactly. Yes. Yeah. So yeah, this has got some lower level kind of cache stuff in there, but yeah, all good. All good. I think there was a question at the back. If you want to pass it up.
No, I'm strong enough to throw there.
Yeah, my question is about the service YAML definition. I understood you made mention of we limiting or maintaining maximum 5 arguments. Am I correct? That if we go above 5 arguments, that means that service is doing a lot.
Yes.
So, if we are to do that, then like how many will you recommend for us to inject in a controller? How many services? Different, probably we end up with about 10 services, but because you said that we should just keep to 5, so how many services can we inject in a controller?
Yeah, I would say 5 is kind of is not an arbitrary, it's kind of a personal preference, I guess. But if you think about solid principles, the more stuff you inject into the class means there's more reason to modify the class to do different things. And it probably means your class is doing too much. So as an example, I was talking about the Microsoft thing. So I've had a service that did the authentication, which used a HTTP service to make that authentication request. So instead of passing both the authentication request and the HTTP stuff into another service to do stuff with, I just passed the authentication stuff in because the original service already had that HTTP request in. And I could then ask for the authentication token and do other things inside that service. So I was basically wrapping a few services in an authentication layer. That's the kind of thing you want to start doing because you can then, if you want to change the authentication mechanism, then you do it in one place. You don't have to start going into all of your classes and start tinkering with them. As I said, 5 arguments is kind of an arbitrary thing, but it kind of points towards your services are doing too much on their own. Does that answer your question?
Yes.
Yeah.
Because sometimes what I do is to have probably 1 or 2 services, 1 service or 2 services, in the sense that I have more than 5 arguments.
Yeah.
And what that service is going to be doing, it do everything for me. So I wanted to request a password generation, it's going to do it. I wanted to pull any API call, it's going to do it, you know. So I just kind of having one place.
Yeah.
But if I have to manage maximum 5, then I will have to now probably create more than 2 services. I may end up with 5 services. I know ideally it's a good way to do things, because you can go to each of the services that is any problem, fix that, and then, you know, come back to it.
Yeah.
But I've been doing that. I haven't experienced any bad luck, but like what you said,
I can see the benefit of doing one service that does everything.
yeah.
But the problem is then it becomes a problem to test that service. Because I'd imagine your testing code is probably 5 times longer than the service itself. So, yeah, it's. Have you seen solid principles? Do you know what I mean by solid?
Yeah, yeah.
Ringing a bell? Yeah.
Yeah, yeah.
So yeah, it's. I think they're called special things. Those kind of classes, like party classes or something, because they do too much and everybody wants to go. You know.
Okay.
So it does sound to perfect preference. If you can maintain that code, that's great. But if you're looking for, you know, if you come to that code in 6 months' time and you go, I need to find where I'm doing password generation, for example, then you can go to the password generation class and figure it out from there. If it's in a big class, you've then got to go searching in your code and try to find which part of that class is actually to do with the password generation. Which isn't necessarily, you know, if you can maintain that kind of thing and you're good at writing, you know, code, I guess, then great. But I find it creates a maintenance problem,
Yes,
basically,
I
in the
agree with
future.
that. Thank you very much.
No worries. Yeah. There is a thank you slide. So thank you very much.